Welcome to Astronomy Daily, your daily source for the latest space and astronomy news. I'm your host, Anna, and we've got a great lineup of stories for you today. From revolutionary signal detection technology in Australia to groundbreaking discoveries by the James Webb Space Telescope, we're covering the full spectrum of astronomical advancement. We'll explore how Krakow, a cutting-edge telescope system, is transforming our ability to detect cosmic signals, and we'll get up to speed with this week's packed launch schedule featuring missions from major space agencies around the globe. The James Webb Space Telescope continues to astound us with its discoveries of massive black holes in the early universe, challenging our understanding of cosmic evolution. We'll also delve into fascinating new research about the universe's first stars and share surprising findings about Martian wind speeds from the Ingenuity helicopter. Plus, we'll look ahead to the exciting prospects of the Vera Rubin Observatory and its potential to revolutionize our understanding of dark energy. Stay with us as we journey through these remarkable developments in space exploration and astronomical discovery. Let's get started. In a groundbreaking development from Australia, astronomers and engineers at CSIRO have unveiled Krakow, a revolutionary telescope technology that's transforming our ability to detect mysterious signals from deep space. Think of it as a cosmic treasure hunter, sifting through an astronomical amount of data to find rare cosmic events with remarkable precision. To put its capabilities into perspective, Krakow processes an astounding 100 billion pixels per second. That's equivalent to searching through an entire beach of sand every minute to find a single 5-cent coin. This incredible processing power has already led to several major discoveries, including multiple fast radio bursts and the detection of 2 previously unknown neutron stars. During its initial trial run, the system surpassed all expectations. Dr. Andy Wang and his team at the International Center for Radio Astronomy Research have already used Krakow to identify more than 20 fast radio bursts, mysterious cosmic phenomena that have puzzled astronomers for years. The system can search for these bursts 100 times per second, with plans to increase this to an impressive 1,000 times per second in the future. The technology operates as part of the ASCAP radio telescope at Inyarimanya Ilgari Bundara, the CSIRO Murchison Radio Astronomy Observatory. What makes Krakow particularly special is its ability to instantly alert researchers when it detects something unusual, allowing for immediate follow-up observations and analysis. This technological breakthrough isn't just about finding cosmic signals, it's about understanding them. Krakow has already helped detect long-period transients, mysterious objects within our galaxy that we're only beginning to understand. These discoveries are reinforcing Australia's position as a leader in radio astronomy, engineering, and research, with the technology soon to be made available to astronomers worldwide through CSIRO's Australia Telescope National Facility. The implications of this technology extend far beyond its immediate discoveries. By providing astronomers with unprecedented capabilities to detect and analyze cosmic signals, Krakow is opening new windows into understanding the universe's most enigmatic phenomena, from the nature of fast radio bursts to the behavior of neutron stars. Now, let's take a look at what's headed for space this coming week. And this week's launch schedule is packed with activity across multiple continents, showcasing the increasingly busy nature of our space industry. SpaceX leads the charge with 4 planned missions, utilizing all 3 of their active launch sites. Among these are multiple Starlink satellite deployments, continuing their efforts to expand global internet coverage. Blue Origin is preparing for a fascinating, uncrewed New Shepard flight that will carry out groundbreaking research. The mission will host 30 payloads, with NASA contributing 17 different experiments designed to test technologies for future lunar missions. What makes this flight particularly interesting is its ability to simulate lunar gravity conditions. The capsule will spin at approximately 11 revolutions per minute, creating an environment that mimics the moon's gravitational pull for about 2 minutes, significantly longer than previous simulation methods. India's space agency, ISRO, is set to launch their NVS-02 navigation satellite aboard a GSLV Mark II rocket. This satellite will join India's Navi-C constellation, providing enhanced positioning accuracy across the Indian subcontinent and extending roughly 1,500 kilometers beyond its borders. The satellite carries cutting-edge technology, including an indigenous atomic clock that uses rubidium atoms for ultra-precise timekeeping. Meanwhile, Japan is preparing to launch their H3 rocket, carrying the Michibiki 6 navigation satellite, which aims to improve GPS accuracy from meters to centimeter level precision. The Spanish military is also joining the launch manifest with their next-generation telecommunications satellite, SpainSat NG-1, scheduled for deployment aboard a Falcon 9. Rocket Lab rounds out the schedule with another commercial launch from their New Zealand facility, continuing their series of missions for French customer Kinéis. This diverse array of launches demonstrates how space access has become increasingly routine and commercially vital, with applications ranging from navigation and communication to scientific research and technological demonstration. The pace of launches we're seeing this month suggests we might be on track for a record-breaking year in orbital missions, highlighting the growing importance of space-based infrastructure in our modern world. Next, an exciting update from the JWST. The James Webb Space Telescope has made an extraordinary discovery that's challenging our understanding of the early universe. Astronomers have identified several supermassive black holes that appear to be far too massive compared to their host galaxies, breaking the rules we thought we understood about galactic evolution. In our nearby universe, supermassive black holes typically have masses equal to about 0.01% of their host galaxy's stellar mass. However, these newly discovered black holes from the early universe tell a dramatically different story. Statistical calculations show they possess masses equal to roughly 10% of their host galaxy's stellar mass, making them approximately 1,000 times more massive than expected. These findings were made possible through Webb's observations of what astronomers are calling little red dot galaxies. These peculiar objects existed just 1.5 billion years after the Big Bang, when the universe was merely 11% of its current age. Their reddish appearance comes from the gas and dust surrounding actively feeding black holes, creating what we call active galactic nuclei. The discovery could help solve one of astronomy's most perplexing mysteries: how supermassive black holes manage to grow to such enormous sizes so quickly in the universe's youth. Traditional theories suggest that black holes should take more than 1 billion years to reach such massive proportions through standard growth processes like mergers and steady accretion of matter. One possible explanation is that black holes in the early universe grew much more efficiently than their modern counterparts, possibly due to the higher density of gas available in the early cosmos. This environment may have allowed them to consume surrounding matter at rates far exceeding what we observe today. These findings suggest that the formation of stars and supermassive black holes in early galaxies might be more intrinsically linked than previously thought. While these ancient black holes appear to have grown at extraordinary rates initially, the star formation in their host galaxies eventually caught up, leading to the more balanced ratios we observe in nearby galaxies today. And while we're talking new research findings, new research is shedding fascinating light on two very different aspects of our cosmic neighborhood, from the universe's first stars to the winds on Mars. Let's start with an intriguing study about the earliest stars ever to exist, known as Population 3 stars. These cosmic giants were thought to be some of the most massive stars ever formed, but scientists have now discovered that their growth wasn't limitless. Through detailed simulations that incorporate magnetic fields, a factor previously overlooked, researchers found that these ancient stars could only grow to about 65 times the mass of our Sun. This is significantly less than previous estimates that suggested masses of up to 120 solar masses when magnetic fields weren't considered. The key finding here is that magnetic fields acted as a natural brake on star growth, even before other limiting factors like radiation pressure came into play. These fields worked against gravity, restricting the amount of gas that could fall onto the forming star. This new understanding helps explain why we don't see evidence of even more massive stars in the early universe. Meanwhile, closer to home, NASA's Ingenuity helicopter has been revolutionizing our understanding of Mars's atmosphere. During its remarkable 72 flights on the Red Planet, this small but mighty aircraft has recorded wind speeds that are considerably higher than what our models predicted. Previous estimates suggested Martian winds wouldn't exceed 15 meters per second, but Ingenuity encountered speeds as high as 25 meters per second at various altitudes between 3 and 24 meters above the surface. This discovery was made possible through an ingenious method, using the helicopter's own tilt during flight to calculate wind speeds. Just as a drone on Earth needs to tilt into the wind to maintain its position, Ingenuity's tilt measurements provided crucial data about Mars's atmospheric conditions. These findings are particularly valuable for future Mars missions, especially as we plan more aerial vehicles like the upcoming Dragonfly mission to Saturn's moon Titan. Understanding these wind patterns is crucial for designing spacecraft and planning missions that can safely navigate alien atmospheres. Finally today, looking into the future. Exciting developments are on the horizon as the Vera C. Rubin Observatory prepares to begin its operations from its home atop Cerro Pachon in Chile. This cutting-edge facility is about to embark on an ambitious 10-year survey that promises to revolutionize our understanding of the cosmos, particularly when it comes to exploding stars. Scientists predict the observatory will detect millions of what are playfully nicknamed vampire stars, white dwarfs that steal material from their companion stars until they explode in spectacular fashion. These explosions, known as Type Ia supernovas, are particularly valuable to astronomers because they always release the same amount of light, making them perfect cosmic measuring sticks. Think of these supernovas as celestial lampposts. If you know how bright they should be, you can figure out how far away they are by how dim they appear. This makes them crucial tools for understanding how our universe is expanding and the mysterious force behind this expansion: dark energy. The observatory will scan the entire southern sky every few nights, giving astronomers unprecedented opportunities to catch these stellar explosions in action. It's expected to generate a staggering amount of data, up to 10 million alerts embedded in 20 terabytes of information every single night. This wealth of data could help resolve some pressing questions about dark energy, which makes up about 68% of our universe's energy budget. Recent observations have suggested that dark energy's strength might not be constant as previously thought, and the Rubin Observatory's observations could finally help us understand if and how this mysterious force is changing over time. This new era of observation represents a fundamental shift in how we study the cosmos. The sheer volume of data will require new methods of analysis, setting the stage for the next generation of astronomical discoveries and our understanding of the universe's ultimate fate. And with that, we wrap up today's fascinating journey through the cosmos. Thank you for joining me. I'm Anna, and this has been Astronomy Daily. If you'd like to stay updated on all these exciting developments in space and astronomy, head over to our website at astronomydaily.io, where you can subscribe to our podcast and catch up on all the latest space and astronomy news with our constantly updating newsfeed. Want more space content? You can find us across social media as Astro Daily Pod. Whether you prefer Facebook, X, YouTube Music, Tumblr, or TikTok, we're there sharing the wonders of the universe. Feel free to leave us a message on our website. We always love hearing from fellow space enthusiasts. Until next time, keep looking up and stay curious about the cosmos.